9/4, and then plus
23 over
20.
23 over 4.
23 over 4.
Sorry.
Oh, it's all right. You don't have to apologize. Everyone agree with that? And now these already have the same denominator, don't they?
Yes.
So when you have the same denominator, we do not want to do that little formula because it's already where we need to be. So here we just add across the top, which would be 32 over 4, and that's 8. So I guess we did finish it. It's 8 pounds, right? Now, because it's a word problem, you want to get into the habit of actually answering the question, which was, how many pounds of candy did Dolores sell to her first 2 customers? 8 pounds. LBS for pounds. Oh, LBS, they didn't use LBS. LBS, period, is the abbreviation for pounds. All right, next table. And feel free, if you want to name your table, like, team whatever, you can. You don't have to come up with a name today. But let's let the next table, we'll call you table 2 for now because you're going to do number 2. I'm going to bring this up here. It's the language arts one. Wait, hold on. Who are you? It's all right. Where are you? Okay, what's your name? I didn't hear you. What?
Rachel?
Rachel. Elliot?
Yes.
Okay. If you see this next time and you see a cross through your name, that doesn't mean you weren't here. It's just that's how I'm counting that you did something. Okay, Rachel. Like I said, I'm not going to remember your name, but I'll make it sound like it for now. Rachel, please.
So turn 5 1/2 to a fraction.
Okay.
11 over 2.
Okay.
And then you're gonna, it's like a division problem, but you're gonna turn it into multiplication.
Okay. So what are you going to divide? You're saying this is division. What do you want to divide? Like, how do you want me to?
11 over 2, then 44 over 1.
Okay, so let me write this down. You're converting this first. So does everyone agree that that's 11 over 2? And then 44, I have these 2 numbers, right? Okay, those 2 numbers are what we are working with. And you're saying this is division. Does everyone agree this is division? Okay, now the order in which you do this division matters. Because think about it this way. Is there a difference between me saying 8 divided by 2 versus 2 divided by 8? Are these are different, right? So multiplication doesn't matter, right? If I say 2 times 8, it's the same as 8 times 2. But when you do division, it's not the same way. 8 divided by 2 is not the same as 2 divided by 8. So how do we need to write this? Do you want to keep going, Rachel, or do you have a question on that? Does anyone want to help? What's that? So which one is going to go first? I think we have 2 options. We have this, or we have this, right? Those are the 2. So which one is it? The second one? Do you all agree with that? Okay, so this one right here is saying, okay, you have 11 halves, whatever that is, and you want to divide that into 44 different pieces. This one is saying you have 44 and you want to divide it into this many pieces. So this is being divided into that. Here, this is being divided into that. Like, think about it this way. How many times does 2 go into 8? 4 times, right? How many times does 8 go into 2? It doesn't. So the answer to this would be a fraction. This would be a whole number, right? The answer to this is 4. The answer to this is 1/4. Okay, so division, absolutely important that you understand which one goes first. So we are going to do this one. Yes? All right, let's go ahead and work it. It won't take too long, I don't think. If I'm going to do that, I'm going to rewrite 44 as 44 over 1 because that's how we rewrite a whole number as a fraction. And then we convert division into multiplication and we flip the second fraction over. Isn't that what we do? And then what? Oh yeah, you can actually do some simplification first. There's a number that goes into both 44 and 11. 11 goes into 11 once. 11 goes into 44 4 times. And so this is really 4 over 1 times 2 over 1, which is really just what? 8, right? 8 over 1, which is 8. And 8 what?
Teams.
8 teams. So you can see that really like the challenge with the word problems is not necessarily, well, hopefully it's not the arithmetic, it's the getting it to the right math problem, right? All right, where's team 3? Don't want to be team 3? Sure, okay, good. All right, so we have team 3 up front here. Dennis has a dog. Dennis's new dog weighs 127 3/4 pounds. That's a big dog. That's a big dog. His friend's dog weighs 94.5 pounds. How much more does Dennis's dog weigh than his friend's dog? So do we have any volunteers at this table yet? I don't need the answer. I just want to know how you're going to set it up. That's the thing that I'm more concerned about. Good. What's your name?
Yesenia.
Yesenia. Okay. How do you say your last name?
Covarrubias.
Okay. I'm not good at rolling my R's. I've never seen that name, ever. I mean, I've been doing this for a long time. It's unique. All right, so what do you, I see you writing, that's why I'm calling on you. What did you write down?
I made into a proper fraction. So
Okay.
511 over 4.
Okay, so you actually converted this one into 511 over 4. And then you did this one over here. You convert that one yet?
No.
Okay. What are you going to do with them, though, once you get them? Do you know? Subtract. So does the order matter when you subtract?
Yes.
Absolutely. You have to have the right one in front. You know, it depends on what the question is asking. So if you want to know how much more does Dennis's dog weigh than his friend's, you're going to subtract the friend's dog's weight from Dennis's dog's. So you have to put Dennis's dog minus this one. So 188 over 2. 9. I forgot to add the 1. Thank you. There we go. And so at this point, you could do however you want. You could get your common denominator, or you could do that little cross thing. It's all up to you. Do y'all want to stick with that little cross thing, or what? Okay, so from here to here would be what? 1022. And then from here to here, 756. And you can use your calculators for this, of course. And then 4 times 2, right, which is 8. And what do you get? 1,022 minus 756. To what? 266, and then over 8. Now that reduces. Is everyone getting that? You have a problem?
If I change it to a decimal instead of doing that, will it be kind of wrong?
That's a great question.
Should I change mine to 127.75 minus 94?
That's not necessarily a problem. For me, it's not a problem. Here's the thing. I want you to know how to do the arithmetic, okay? Because the calculator, of course, will get you an answer, right? But it's, you know that 3/4 is 0.75, right? What if it was something like 5/8? Like, you know what I mean? Like, are you going to know the decimal, or are you just going to decimal no matter what?
No, it's just if it's like a basic
Yeah, if it's something three, I don't mind that. Just make sure you know how to do the arithmetic and the simplification. And when you get your answer in a decimal, you need to get it back to a fraction. All right, so I'm reducing this. What goes into both of those? 2?
Yeah.
2 for sure goes in. It goes in 133 over 4. And does 4 go in there? No, right? So now you go and try and turn that back into a mixed number. So this is where you do that old school division like this. You try and see how many times it goes in. So 4 goes into, doesn't go into 1, goes into 13 twice. Gives you 3. I even put 12 here. I don't know what I'm thinking. Okay, and then I'm left with 13 when I subtract, and then a 0. However you do this. Remember I said there are certain things I assume you know how to do. This division is something I assume. 4 goes into 13 again. 3 times 12, 1 left over. So I'm going to have 33 and a quarter. 33 and my remainder over the divisor. So this is 33 and 1/4 pounds, right? Now later on as the semester progresses, we will not take this much time to do this sort of arithmetic. Like on exam 1, I want to see that you can do this, but as we go through, we will be using our calculators more to just do this like arithmetic sort of thing, all right? Okay, let's see. How many more problems are there here? Okay, there's just a few more. So let's see. Group 4 is the next table back. So give you some time to read through that. And then I will take a volunteer. We're going to actually have to take a break at some point. We're supposed to have a 10-minute break in this class, which you may want. I don't know. If we don't do a break, I can let you go 10 minutes early. It's kind of up to you. Let's get through this one, and we'll see if we want a little break. Okay. Anyone? Anyone? Okay, you are?
Carlos.
Carlos. Okay, Carlos. What'd you say? Do what?
12 over 5/8.
Is the answer.
Yeah.
What did you do?
I put 30 and 1/2.
Okay.
Minus 17.
Okay, so minus 17. So this is the actual problem that you're setting up. Does everyone agree with that? All right, so the important thing is that you can read that problem and get to this. If you're having trouble with that, then of course that's what we need to work out. But everyone's okay? I'm not going to do the arithmetic. You said the answer was what?
12 and 5/8.
12 and 5/8. Now, I haven't worked through this. I'm put a question mark next to it, so everyone can check Carlos's work at some other point. We don't need to do it now. Did anyone else get this yet? Yes? Okay, so we have at least 2 people that verify that that's the correct answer. So you're doing 30 and a half miles per gallon. Returns, and how many more miles? Yeah, so how many more means what's the difference between the two? All right. Number 5. And we'll go with the two top over there. Less brain power, but you two look like you've got this. It looks like you, numerically, I'm not saying that saying there's less people, less brains at that table, right? But I'm confident. Any ideas?
I think you have to start with 2.5 divided by the 3 friends.
2.5 divided by the what?
3 friends.
You have to multiply. 2.5.
Okay, hold on. Let them think through it. Jerry bought 12.5 pounds of candy to share with his friends, right? If he gave 2.5 pounds to each of his 3 friends, how much candy does he have left? So look, this is the first problem that's requiring a little bit more thought than the others. I've always done this. Any word problem I've ever had where I've been confused about what to do, I've always tried to just rethink the problem with easier numbers. Okay, so let me give you an example. Let's say I change this to 20 pounds. All right, that's a nice number to think about. Let's say Jerry had 20 pounds of candy. Let's say that he gave, instead of 2.5, let's say he gave 2 pounds to each of his 3 friends. Right? How much would he have left over? So how much candy did he give away? He gave away 2 pounds to his 3 friends, so he gave away 6, right? How did you get that 6? What did you do to get 6? You did this number times 3, didn't you? And that gave you how much he gave away. So how much would be left over? He started with 20, right? He gave away 6, so he'd have 14 pounds. Does that make sense? That's the way I like to try and work with problems if I'm having trouble with the numbers. Just use something that makes more sense, and that helps you kind of resolve what arithmetic needs to happen. So we need to first take 2.5 times 3, right? Figure out what that is, and then subtract that from what? 12.5, right? So let's do this first. We do 2.5 times 3. That's going to be the amount of candy he gave away. This is the same as 5 halves times 3 over 1. So all I'm doing here is converting that over to this. 2 times 2 plus 1 is 5 over 2. And then converting 3 to 3 over 1. And this gives me 15, multiplying straight across, 15 halves. That's how much candy he gave away. All right, he gave away that much. Now what? Subtract that from 12.5. Good. So the way you'd write that is 12.5. You're saying subtract this from that, so like this. All right, what was your name, sir? I'm going to give you this one.
Brian?
Brian Thompson, all right. Did that help at all with me using different numbers? Did it? I mean, using the 20 and the 2, did that help? I hope it did. I mean, that's actually what I do a lot of times, just to make the math make sense first, like what the operations are, and then I go do those operations. All right, I'll let y'all take that the rest of the way. You would convert this over, get 25 halves, and then subtract, and let's move on. Should we finish these last ones and then take a break, or do y'all want to keep going? Finish this one? This is the last one right here. This is table 6. This one looks complicated, but I haven't even read it yet. I haven't worked any of these problems out in 2 years since the last time I taught this class, so you're looking at them kind of at the same time I am. Oh, look at them. They want to be different.
So I think we need to divide
You are?
Adam.
Adam. Where are you, Adam? There you are. All right, Adam, you need to do what?
Divide 23 2/5 by 4 1/2.
Okay, take 23 and 2/5 and divide that by 4 1/2. That's it? And that'll be the answer?
I believe so.
Okay, again, I haven't read the problem, so I'm just taking what you're giving. Now, let's see, do you all agree with that? No? We have a disagreement? Okay. All right, so they decided to go around the track to see how many times they could run around the track without stopping, right? When they finally finished, their stopwatch showed they each ran a total of 23 and 2/5 minutes. if on the average, Joy also knew it took them 4.5 minutes to run around the track once, how many times they make it around the track? This is just confusing. Just the wording is confusing, isn't it?
It's asking how many times they completely made it around, not the, it's gonna give you an improper fraction.
Okay, so it says how many times did they make it around the track means that when we, so do you agree that this is the correct, so this will get us an answer, but that won't be the answer that we're looking for because any fractional part that they ran around doesn't count. So it's like, you know, if they start here, and let's say they start running around, they go around once, and they go around twice, and then they stop there, right? If that's where they would get, then they didn't go around that other time. So we don't count that as how many times they went around. Does that make sense?
Yeah.
Okay. All right, so if on average it took them 4.5 minutes to run around the track once, how many times do they make it around track? So let's do the division on this. So if we're going to divide here, what do we need to do? Maybe get them out of the mixed numbers first? So what does that first fraction turn into?
117 over 5.
What is it?
117 over
117 over 5, and then divided by, this one I can do, 9/2. And then flip, right? What did you say? Stay. Copy dot flip. I like that. Copy dot flip. Copy dot flip. Apparently, wherever you learned that, it stuck. Here or no? No? You, high school? Okay. It stuck. It stuck. All right, so multiply 2 times this. 234 over 45. And then you try and work that out back into a mixed number. 5 1/5? So how many times did they make it around the track? 5 times. 5 times. So that's what you were saying, is that this answer is not the correct answer to the problem because they say how many times they make it around? 5 times. All right, do we want to break? Yeah, a little 10 minutes is what we get. So it's 12:25. Let's be back here at 12:35. And I think I'll stop the camera. That's what I'll do. How are we doing here?